In this question, we are looking at creating a curve sketch. In our first question, we want to know where the x and y intercepts are. The y-intercepts are where x equals, if you let x equal 0, what is y? So for y-intercept, let x equal 0, or y of 0 equals 1 over 1 minus 0 squared, is 1 over 1, which equals 1. So there's a y-intercept at 1. X-intercepts are the roots of the numerator. There are no roots. As there are no roots, this is there are no, or sorry, no roots in the numerator. There are no x-intercepts. Okay. Now, it doesn't ask about any asymptotes at this point. It might look for asymptotes later. Well, it does, but for now, that's all it is. X-intercepts, y-intercepts. Now, determine where the function's increasing and decreasing. To determine where the function is increasing and decreasing, I need to look at f prime of x. I need to look at the sign of f prime of x, or the derivative, or y prime. Now, to do this, I'm going to use the power rule. So I'm going to have y equaling 1 minus x squared to the minus 1. This becomes multiplied by the power decreased by 1. This becomes minus 1 minus x squared to the minus 2 times minus 2x, which equals 2x over 1 minus x squared squared. Okay. To determine where we're increasing and decreasing, we want to find all the critical values and create a sign chart about that. So to do this, I want to factor this expression, numerator and denominator. 1 minus x, 1 minus x, 1 1 plus x, and each of these terms are squared. I'm going to construct a sign chart about these values. These values are, from the numerator, x equals 0, and from the denominator, x equals plus or minus 1. So constructing a sign chart, I have at about 3 points, minus 1, 0, 1, and I have the expression 2x, 1 minus x squared, 1 plus x squared. 2x is positive when I'm greater than 0, and negative when I'm less than 0. X minus 1 squared is positive everywhere. Same with x plus 1 squared, which means I'm negative, negative, positive, positive. So I'm decreasing, decreasing, increasing, increasing. So f of x is increasing for x in the interval 0 to 1, union with 1 to infinity. F of x is decreasing for x in minus infinity to minus 1, unioned with minus 1 to 0. Now it asks us to compute the location and behavior of any asymptote. So there's two asymptotes we could have, vertical and horizontal. For our vertical asymptotes, I look at this expression and go, this is 1 minus x, 1 plus x on the denominator. So there's a potential at x equals minus 1 and x equals 1. And then I also have my horizontal, which is looking at the limit as x approaches infinity and of y, and the limit as x approaches minus infinity. Now, to help with this, I like to create a sign chart of my function, which here is going to be built around minus 1 and 1, 1, 1 minus x, 1 plus x. This is positive everywhere. This is negative, positive, 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 negative. So negative, positive, negative. So if we take a look at the limit as x approaches minus 1 from the negative of 1 over 1 minus x, 1 plus x, this equals 1 over 0. And now, if I look from the negative, it's minus infinity as I'm negative. It equals minus infinity as we are negative just before x equals minus 1. Similarly, if we take the limit as x approaches minus 1 from the positive of 1 over 1 minus x, 1 plus x, this equals 1 over 0, which equals infinity as we are positive just before, just after x equals 1. And if we take the limit as x goes to infinity of y, we get 1 over 1 minus infinity squared, which equals 1 over minus infinity, which equals 0. And this equals 1 over 1 minus infinity squared, which equals 1 over 1 minus infinity, which equals 0. So we do have a horizontal asymptote of 0. At x equals 0. Here we have a vertical asymptote at x equals minus 1. And there's a similar argument for vertical asymptote at x equals 1, which I will leave for you guys to work through yourself. And now from here, what we're going to do is we're going to take this information, incorporate it into the graph for what we have right now, and then we're going to add some additional detail. So first thing that I'm going to do is I'm going to plug in where I have my asymptotes. So I have an asymptote at minus 1. I have an asymptote at 1. Then I have where am I positive and I'm negative. I am positive for x in the middle here. I'm negative here, negative here. And then I have a horizontal asymptote here and here. I have a vertical asymptote here and here. Vertical here. Vertical here. I know that I'm decreasing. I'm going down, down, up, up, because I'm decreasing from minus infinity to 0, or minus infinity to -1, and -1 is 0, and I'm increasing from 0 to 1 and 1 to infinity. The last thing I have is points of inflection. Are there any points of inflection, and where are we concave up? And to do this, I need to look at y double prime. This is the second derivative of my function. For this, some will like quotient rule, some will like product rule. We have y prime equals 2x over 1 minus x squared squared. So when we look at the second derivative, the derivative at the top is 2 times 1 minus x squared squared minus 2x times 2, 1 minus x squared times minus 2x all over 1 minus x squared to the 4, which equals 2, 1 minus x squared squared plus 4, or plus 8x squared 1 minus x squared all over 1 minus x squared to the 4, which equals 2 minus x squared plus 8x squared over 1 minus x squared to the 4, which equals 2 plus 7x squared over 1 minus x to the 4, 1 plus x to the 4. Now here, there are no roots in the domain. Oop. So as there are no roots in the domain, thus no points of inflection. What are the roots? The roots are -1 and 1. We can construct a sign chart about these roots. -1, 1. We have 2 plus 7x squared, 1 minus x to the 4, and 1 plus x to the 4. Or sorry, 1 minus x to the 3, 1 plus x to the 3. Well, our 2 plus 7x squared is always going to be positive. 1 minus x to the 3 is going to be negative when I'm greater than 1 and positive when I'm less. 1 plus x to the power 3 is going to be positive, positive, negative. Multiplying these together gives negative, positive, negative. So I'm concave down, concave up, concave down. But these are not inflection points. The reason that they are not inflection points is because they're not within the domain. But I'm concave down, concave up, And remember, we go through the point 0, 1. Concave down. We have a horizontal asymptote, x equals 0. And that is our sketch.